And welcome to our space weather bonus features section. Our daily space weather videos have recently changed. We've been splitting them into 3 separate segments here to cover a little more stuff with a little bit of less time. So, space weather can cause satellite charging hazards. We only see minor ones here over the Central Pacific. Just some minor surface charging hazards there, not a lot to worry about there. Next, we'll look at the electron flux. There's the 1-year chart of the greater than 2 mega electron volt electron flux, or fluence. And we've just gone back into warning territory here on the GOES 16, not so much with the GOES 17. We actually see a divergence here. We see the GOES 16 going up and the GOES 17 going down in terms of its measured electrons. These satellites are measuring from their geosynchronous near equatorial orbit the F-ionosphere layer's free electrons. Here's a forecast model. And we are expecting a dip here. I would tend to agree with a dip in the electron flux when the coronal hole wind stream that's forecasted arrives. Make sure you watch our previous videos if you don't know about that. And next we're going to show you the total electron content forecast. Basically the electrons in between your geosynchronous GPS satellite and your handset, those are orbiting at about 12,500 miles of altitude. And they've got to communicate through the plasmasphere and the inner Van Allen belt. And there can be a lot of electrons there. They tend to be concentrated around the equator at noon. We'll let it play through a second time here. We've got some significant chaos. Some significant GPS errors happening here at nighttime. Also over North America there at nighttime and in the daytime. And you would expect larger GPS errors south of the equator as it is summertime down there. Next, the ionosphere. The F layer is located at about 300 kilometers of altitude. Feel free to pause the video on this frame if you want to look more deeply at it here into the penetration of electromagnetic radiation, the temperature of the thermosphere, and the molecular composition of those layers. So here's just the F ionosphere layer, one slice in vibrational frequency. Megahertz are millions of vibrations per second. They used to be used to measure computer processing times. Now we use gigahertz, billions of calculations per second. This is millions of vibrations per second in the F layer. We'll also show you the anomalygram. Here's the anomalygram showing anomaly in megahertz from the 30-day median. We are seeing continued anomalous zones here around Central Africa, where we're seeing significant and consistent swings, probably telling us something about the inner workings of the Earth. The structures that are not visible, that are underground. There's a lot of stuff going on under the surface of planet Earth. And this gives us some insight into it, as the bridge between Earth and space is affected by Earth's internal structures. Anyway, there's the latest image in ionogram, reaching some high frequencies there, all the way up to 14 megahertz. That's 11:30 Universal Time. Here is the anomalygram, 11:30 Universal Time. You can see those wild swings in the ionosphere there, once again over Central Africa. Next, we'll take a look at some recent images here from the National Sunspot Observatory located in Cerro Tololo, Chile. Some filamentary behavior going on up here. Quite a few filaments here in the Earth-facing zone here. Only 2 named sunspot groups at the moment, so low levels of solar activity. Make sure you watch our previous videos for a deeper dive into that. And next, the latest high-resolution intensitygram and high-resolution magnetogram. So this is a basic sunspot. It's only alpha class, and so is this one. There is a beta class group trying to form there, so that has gotten a little more complex since we did our show prep. Up here, this is barely a sunspot. So we've got 3 groups that are legit and 1 trying to form there. If that does form, that would be the most likely spot to see significant flaring. There are the magnetic fields, and you can see there is a strong North Pole field following the leading umbra there. They're pretty minor. They've got to be in place for about 12 hours in order to get a name. There are the fields of the other active regions. And there's that tiny sunspot in the north. Thanks to the Smash team, the true source of funding for the content, we replaced Patreon with something superior. Smashamatch.com/Smash team. Links below the video to that. Here's the GOES 16 SUVI imagery. And we see some filamentary behavior going on up here in the northeastern corner, which would be your screen upper left. Great up-to-date imagery there from the NASA GOES 16 SUVI. And we'll close out with two more sets of images here from the SDO. This is the 131 angstroms wavelength, part of the ultraviolet light spectrum. And like 94 angstroms, which we covered in an earlier video, this one's good at showing solar flares, as it takes an image every 2 seconds instead of an image every 10 seconds. So 5 times as much temporal resolution there from the 131 angstroms and 94 angstroms. Let's close out things with ionized helium, 304 angstroms from the Solar Dynamics Observatory. Thanks for tuning into our bonus features section. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, Least Busted, Name and News.